Okay, you guys, last time we were here, we cut out those four pieces. What I'd like you to do is sometime, I'm going to get you the glue sticks later on, but I'd like you to take those four pieces of the quadrilateral. You threw them away? Okay. Well, you guys, if it helps remind you, what I'd like you to do is paste them, the cutout pieces, paste them into your notes, with a glue stick or something, so that you can see that the four angles of the quadrilateral add up to 360, okay? So, hey, we're going to go through these notes on this worksheet I just gave you, front side right here. So, starting with quadrilateral. What is a quadrilateral? Okay, wait. I want a couple definitions by raise of hand. Okay, go ahead. A shape with four or more sides. Okay. I'm gonna give counter examples if I don't think it's quite precise, and you guys kind of fix it. Here's a shape with four sides. Okay. Oh, that is five sides. I can fix that. All right. Okay. A quadrilateral with four straight sides. Okay. Let's see if I can come up with something else. What do you think? Is that a quadrilateral? Technically it is. Yeah. Hey, let me give you the definition that we'll probably do. You guys, this is called a concave. This is called a concave polygon, or a quadrilateral in this case. Okay, because it has one side where the vertices point in. Okay. Um, we're going to study what we call convex quadrilaterals, where all the vertices point out. Okay, so you can't have any like this one right here where it's pointing in. Okay, so probably what we need to do, and that's one thing about this. Did you guys learn the definition of polygon last year or any other time? I'm guessing by what we're doing right here is that you were supposed to have this in like Math 8, but you guys didn't have Math 8, so you probably didn't have it, or Math 7. But the definition of a polygon is a figure that's closed. Okay, because I guess I could have done this too. Would that be a quadrilateral? No, because it needs to enclose a space, right? And a polygon always encloses a space. So that one didn't enclose it, so that's not a quadrilateral. Okay, so the definition of a polygon is a shape that has straight sides that closes in an area, and they are the sides of the polygon are endpoint to endpoint. Because sometimes people think, okay, is this a quadrilateral? It encloses a space right here, but what's wrong with the segments? They're not endpoint to endpoint, right? So that's what we get. So here we go. With quadrilaterals, though, we're going to use the word polygon to define it. Okay, it is a polygon with four sides. Because by definition, a polygon encloses a space, and the segments are endpoint to endpoint, and we're going to be talking about convex, not concave ones, okay? So next word, consecutive sides. And I'm going to draw a picture of a quadrilateral, and I'm going to call this A, B, C, and D. And we're going to talk about consecutive sides. What do you think consecutive sides means? Two sides that are consecutive. Which ones? AB would be one, and what's another one? DC would not be it. DC would be opposite. Huh? And AD would be an example. Okay, I like to say it like this. Write it down. You guys ready? Okay. Sides that share a point, or a vertex point. Okay, two sides for consecutive sides. Two sides that share a vertex point. Which vertex point are we sharing right here in this example? A, right? You can put it another way. Two sides that are next to each other. Okay? Two sides that are next to each other. Okay, what do you think consecutive angles would be? Angle A and angle B, right? Are consecutive angles. What's another example? B and C, did you say? Angle B and angle C. Or angle D and angle C. Or angle A and angle D. Okay? So you can write down for angles, I mean, there are two angles next to each other. Or you can put, they share a common side. Like an angle A and B, they share side AB, don't they? Angle A and B share side AB. So you can write that down as your definition. Okay, number 4, non-consecutive sides. What would non-consecutive sides be? A and C are non-consecutive, well, side. We're talking about sides. Yeah, A and C would be an example of non-consecutive angles. Okay, if you want to write that down. AD and BC would be examples of AD and BC would be examples of non-consecutive sides. Okay? Sides not next to each other, if you want to put it like that. They don't share any points in common. Okay, and then what is a diagonal? Does anybody know what a diagonal is? Think of the word. You probably understand it just by the word. What is a diagonal? What, yeah, if someone's diagonally from you, what does that mean? Okay, so give me an example of diagonal. A diagonal. Angle what? Angle B and angle D. And what do you mean angle B and angle D? Because we just gave an example of opposite angles or non-consecutive angles. That would be an example of that, but what is it? A diagonal is we got to classify it. What is it? Is it an angle? Is it points? Is that what you said? It's a segment. It's a segment that connects non-consecutive vertices, okay, or angles. A segment, write that down, a segment that connects non-consecutive vertices. So BD is a diagonal. There's one more in this one. What is it? AC. AC is a diagonal, okay? Non-consecutive vertices. Look, if I connected consecutive vertices, like D to C, why is D to C not a diagonal? Yeah, there's already a line there. It's a side, right? It's got to be non-consecutive. Okay. Going to the next word right here. We're gonna go over 7, 8, and 9 just to make sure we understand this. State whether each statement is true or false. If the statement is false, explain why. Okay, A. Quadrilaterals are named by listing their vertices in order. True. What would we name this one right here? A, B, C, D. Now, is there another way to name this one? D, C, B, A. In other words, we can start with any letter, and we can go either clockwise or counterclockwise, but we have to, if I start with D, I either have to go then A, B, C, or D, C, B, A, right? I have to go in order. I got to go from consecutive vertice to consecutive vertice. Got it? So any polygon can be named that way. So there's lots of names for this, isn't there? What if I started one with C? How could I finish it? Someone said that one. Or CBAD, right? Okay? So there's different ways we can name it. Okay. So the answer to that one was what? True. Okay, B. The segments that make a quadrilateral intersect more than once. The segments that make a quadrilateral intersect more than once. Well, I guess it depends on what it means. Let's say this one is EFGH. And it says the segments that make a quadrilateral intersect more than once. Like this segment right here intersects two other segments, doesn't it? G and F. So I would say that is true. Okay, C. The sides of a quadrilateral can also be called diagonals. The sides of a quadrilateral can also be called diagonals, right? What do you think? The answer to that is what? False. Because if you have EF, those are consecutive vertices, and that's not, by definition, that's not there. Okay, D, the sum of the measures of the angles of quadrilateral is 300. False. Now on all the false ones, what were you supposed to do? Explain why. So what would you do on D? It's 360. Was there another false one on there? C. Yeah, well, C. The sides of the quadrilateral can also be called diagonals. If the answer is false, why? Because they're not consecutive, right? Because the sides are consecutive. You can say that, or diagonals can't be consecutive either way. Okay, 8. Use the diagram of quadrilateral EFGH. In each exercise, use the given information to find the measure. Explain how you find the measure. Okay, if measure of angle E is 70 and measure of angle F is 130, find a measure of angle G. This one you should get. I'm going to draw a new picture of EFGH because they have it way different. And they say this one is 70. And they say this one's 130. How do I find G, everybody? Add them all together and subtract them from 360. What do you get? What do you get? 70? Okay. Any questions on that? Okay, B. If measure of angle E equals X, okay, so we're going to erase these. Measure of angle E equals X, and measure of angle F is 124. And measure of angle G is X plus 20. Find measure of angle G. How are we going to do that? Okay, say that again, Audrey. You forgot one. Plus 90 equals 360, right? All Audrey is doing is adding up the angles. 90 plus 124, these two right here, this one and this one. And x plus 20 makes 2x plus 20. And all we have to do is add 90, 124, and 20. What does that make? 234. So 2x plus 234 equals 360, right? Solve that equation. Minus 234 from both sides. What do we get? What? 126? And then do what? Divide by 2, and what do you get? What? 60? 63, right? Is that my answer? That's really not degrees. It's just x. That's x. So how do I find G? Yeah, 63 plus 20 makes 83 degrees for this angle right here. And what would x be? 63 degrees. So now we know the measures of all four angles. Got it? Okay, go to number 9. To help you remember the characteristics of a quadrilateral, sketch a quadrilateral. Label the vertices. Name the sides, angles, and diagonals of the quadrilateral. So let's just make sure we understand this. Make any quadrilateral you want. Name it whatever you want. And after you get through doing this, I want you to compare it with your neighbor. Now, you guys, your assignment is to finish the back side of this. Plus, I have another piece of paper that has quadrilaterals on there. I'm going to have you finish that, okay? And that's what you're going to do today in class, okay? So sides are AB, BC, AD, and CD, isn't it? Okay, name what was the next thing? Name the angles. Angle A, angle B, angle C, and angle D, okay? And name the diagonals of the quadrilateral. What are the diagonals? BD and AC. Should put segments over them because they're segments. So these are the two diagonals right here. That's all you had to do on that one. Okay? Now in 10 through 14, I think you're using WXYZ right there. Okay? And then find the missing measure in the other ones. Okay,